In this video, we're going to be taking what we've learned from systems of inequalities and finding the feasible region and turning into situations where we're actually modeling with this. So we're looking at contextual situations. Really, this is going to be broken down into two parts. In the first video, we're going to be looking at how to create the inequalities and to figure out which of these systems would actually work. In the second part, we're going to be looking at different pieces like solving with graphs and actually solving to find out what the answer should be. So in the first example here, we have that VJ needs to take a taxi, which costs a flat fee of $3. So in other words, when he gets in that taxi, no matter what, he's going to pay $3. So I'm going to underline that piece of information because it seems like it's very important. Plus an additional $4 per mile. So based on our knowledge of the structure of linear equations, I'm going to label some of this because I think it will be very important. That first part, a flat fee of $3, sounds like an initial value. Before anything's happened, we're going to pay that amount. Plus an additional $4 per mile, that part sounds like a rate of change. And I think miles will be our input variable. So the first part of this, we want to write an expression in terms of m. So m will be our variable, which represents the cost of the ride. So again, our initial value is $3, and we know that we're going to pay $4 for every mile, so that's my rate of change, and then my input variable is m. So I've created the expression. I haven't really done anything yet because the next step is I want to actually do something with this, find out an inequality that can work. So that's going to represent whatever the cost is. What they're telling us in the next part is that he's got $. Which inequality shows the number of miles he can afford to travel? So we're going to take that inequality, the 3 plus 4m, and we know that no matter what, because that expression represents the cost, what he spends has to be less than or equal to what he has. So we know that expression has to be less than or equal to a. Now, based on just that information, I can't solve this problem yet because it looks like all of my inequalities, the choices, have m isolated. So that's the next step is I'm going to try and get m by itself. So I'm going to take 3 away from both sides and then divide by 4. And what I have is m is less than or equal to a over 4 minus 3 over 4. Based on that, I know that A and C are not going to work. So you might be leaning towards D is the correct answer, but that's actually showing kind of the opposite, that the number of miles is greater than or equal to whatever his cost is. And that's not really true. He can't spend more than he has. So actually, B ends up being the correct answer, but there's an additional piece of information that kind of throws us off a little bit. It's at 0. And what this is actually called a compound inequality. We have two inequalities together as one. And m being between those two variables says it's got to be between 0 and whatever that a over 4 minus 3 over 4 is going to equal based on what a equals. The reason that we have to include that 0 there is because in theory, he could travel 0 miles. And that would essentially mean that VJ gets into the car, pays the cabbie $3, and then just gets out. It's highly unlikely, but it's certainly possible. All right, let's look at another example, similar in structure, but a little different context. In order to bring his business to the next level, Christoph wants to gain at least 2,000 followers on a popular social media platform. So wants to gain at least, there's that keyword, at least 2,000. From his own personal account, he knows that each original post, so original post, gains him approximately 3 new followers, and every 5 reposts gains about 1. So we're going to take that information and try and create an inequality from this. What we're trying to find is the number of posts, so those are his original posts, and then R is the number of reposts to get him at least 2,000 followers. So the fact we have at least tells me that this whole thing has got to be greater than or equal to 2,000. So just based on that information, I know it can't be B, and I know it can't be D. Where it gets a little bit tricky is looking at that R variable, the coefficient on R. Instincts might tell you that this is the correct expression here for R because it's got the 5 and the R. But remember that it's not every repost gets him 5 followers. 5 reposts gets you a follower. So essentially what he's getting is 1/5 of a follower for every repost. So 1/5 as a decimal would be 0.2. And this also fits the other situation that if we have 3 original posts, he's going to get 3 additional followers. So A would be our best choice. 3P, so 3 times the number of original posts, plus 0.2R, so 1/5 of the number of reposts, has got to be greater than or equal to 2,000, because that's his goal. He wants to have at least 2,000 followers. One more example, and this is more of the full brunt of system of inequalities because we have multiple inequalities at one time. It's not like the previous ones where we just had basically a linear inequality. This has multiple. So again, what we want to do is first read through the prompt, highlight, subsearch, underline, whatever, some really important information that we think is going to help us find out which system is the correct one. A company manufactures cellular phones and laptop computers. The company's daily production of cell phones, there's a variable, must be more than 500,000. Daily production of laptop computers must be more than 300,000. So just based on that, I'm leaning towards a couple of choices here. The maximum capacity of the company's manufacturing center is no more than 950,000 total. Which of the following systems of inequalities best models the situation described as above? So I'm going to take those pieces of information that I underline and create inequalities based on that. So the number of phones must be more than 500,000. Again, not at least, but more than that. So that would be C is greater than 500,000. Laptops must be more than 300,000. And together, I can't produce more than 950,000 of them. So I'm going to take the number of cell phones, which again was C, plus the number of laptops, which is L. And because it's no more than, I can make 950,000, but I can't make more than that. I can certainly make less. It has to be less than or equal to 950,000. So I'm looking for the system of inequalities that shows me that, and I know that A and C are out because of the greater than or equal to versus the greater than. And I know that B is out because that's showing me that the number of cell phones minus the number of laptops has to be 950. That's not how production works. We're putting them together because we need to know the total number of units produced. So it's the number of laptops plus the number of cell phones has to be less than or equal to 950. So D would be our correct choice. So again, picking out that key information, underlining, highlighting, whatever you need to do, will definitely help us create the inequalities that we need, and then we can look to figure out what the actual system is.